In this video, we'll discuss matter and how it's classified. So matter can be classified into two categories, pure substances and mixtures. Pure substances can be categorized as elements and compounds. Mixtures can be classified as heterogeneous and homogeneous. Elements and compounds, I think that's pretty straightforward. Heterogeneous and homogeneous is a little tricky. Think about heterogeneous as sometimes having layers or chunks, but homogeneous is an even distribution of the particles in that mixture. So here's an example of iron versus iron oxide. So iron is the pure element as you would see from the periodic table, but iron oxide is iron bonded to another element. So that's a compound. Notice how they look very different. So an element is a pure substance of only one type of atom, where a compound is two or more atoms of different elements that are chemically bonded. And it's important to understand that just because two atoms are bonded together doesn't mean they're compounds, because you have diatomic elements. So all of these are called diatomic elements. These are elements that are bonded to another atom of the same type. So hydrogen bonded to another hydrogen, nitrogen to another nitrogen. And so all of these you'll find in nature like this: H2, N2, O2, F2, Cl2, Br2, I2. Now mixtures, there are heterogeneous and homogeneous. Notice there's two different types of drinks here, right? You've got one with layers, that's heterogeneous, a mixture that does not have a uniform composition, versus homogeneous, a mixture with uniform composition. Now, if you look at diagrams of these, you can see that element, it's symbolized with just one color and one circle. But compounds, you have red with little blue circles attached to it. Notice that they're attached. That's an indication from this example, this model, that that's a compound. And then look at homogeneous. See how these are distributed fairly evenly. We don't see any layers, but you have compounds and you have elements, and notice how they're not touching. So that would represent a mixture. If it was a compound in a representation like this, the different circles would be touching. Now heterogeneous, notice that we have a layer down here and then we have a layer on top. So it's not uniform throughout. There are several different ways to separate mixtures. You can use distillation. So if you have a mixture of liquids, you can separate that mixture by a difference in boiling point. So if one substance boils at a lower temperature, then as long as you have the temperature higher than that boiling point but lower than the boiling point of the other substance, then you can separate them. And when you do this, when you condense a liquid out of that mixture, it's called a distillate. So let's say you have alcohol and water. Alcohol boils at 80 degrees. They're over here. We're heating them up. If we heat it up to 80 degrees, then we can boil or evaporate some of that alcohol, because the alcohol boils at around 80 degrees. But if you crank it up above 80 degrees all the way up to 100, then you're going to lose both. You're going to lose the alcohol and the water. So you have to make sure that you keep that range between 80 and 100. Another separation technique is called chromatography. And this is where you use a difference in adsorption between the different molecules. And you basically take a mixture of pigments, run a solution through those pigments, and it'll separate into the different pigments that constitute each one of those. Now, when you do this, the process is called chromatography, But the record that you have like this would be called a chromatogram. Filtration is pretty straightforward. You can filter substances based off of their size by passing through a filter. Think about coffee. And then you have extraction, which is a more advanced separation technique where you use the difference in solubility of substances. And so if one substance has a certain solubility, like it's polar, and then another substance in that mixture is nonpolar, then you can use the difference in the solubilities to separate that mixture.